Test move. Very happy and pleased today to have Royce, Dr. Win Royce from TRW to give us our process roundtable. I just want to say two things. I want to thank Stan for having the original idea of the process roundtable, because we've gotten to hear a lot of good things. We're going to hear something good today, I think. I'm pretty sure we are. The second thing I want to do is give you a little bit of history of how this talk came about, and I'm really proud of this, because it started, at least the talk did, started May 29th, when we had the search conference for the process program over at the Holiday Inn, and I happened to be sitting with Win at a break time. If you would gone to that process roundtable with us, it was scheduled down to the minutes. We had like microseconds to talk in between. And he says to me, did you know that the waterfall model has a lot of in-systems engineering? I said, no, I didn't know that. And the other thing that went through my mind was, I'd like to hear more about this, but I know we won't have any time, and Win will never have time to do it. So Watts was walking by the table just then, and we grabbed a member. I said, how about this for a process roundtable? He said, yeah, great. So that's how it came about. We're going to hear Dr. Win Royce on how the waterfall model was influenced by the hardware systems engineering process, and we're going to hear a proposal for how it might be revised. I'll give you Dr. Royce.
Thanks, Ken. There are two parts to this talk. What I want to do is essentially indict the waterfall-like model process point by point on some legacies that it has from really the hardware approach to building hardware. And then at the end, and more importantly, I want to go over my ideas for a better process. And one that you'll see would be utterly unapproved by the military today. It has certain features that just make it hopeless to be approved. But no matter, I think it basically has the qualities that computer science and software engineering need. And I do elicit your own feelings about this. I've deliberately gone out of my way to make some of this provocative. And if you disagree and remain quiet, it's your fault. Okay. I sort of mean this sort of seriously. Most software people don't realize it, but they are doing things that were invented, frankly, for hardware and don't work well for software. And I'm going to try and point out some of those things. In some sense, I expect I did have something to do with this, probably a lot less than I deserve, though. The paper I wrote that has sort of become the software model paper, I wrote it in 1969, and I was looking back on work we were doing in 1963 and 64. And during the 50s, I got out of college with my master's degree in 1952. And for the next 10 years after 52, I was very deeply embedded in what was called system engineering. And system engineering, frankly, was invented during the mid-50s. And so I was kind of there watching the invention take place. I was much influenced by it. I thought it was the right way to go. And when we built this software in the early 60s that caused the waterfall model paper to be written, frankly, to whatever my contribution was, I was thinking about my system engineering roots and trying to change the way that we were doing things to fit that. And so system engineering and some hardware thinking, which I was very under the spell of, definitely entered the way we did this. And then eventually when I wrote this paper, it's in there. Now I want to criticize my own feelings about that, in a sense, sort of happily. Okay, here is the agenda, and the first 6 points are the areas I want to talk about, in which there is, I feel in each case, some legacy from hardware which affects the way the software process, the approved software process, arose. And in most cases, I'm going to characterize this as bad. In a couple of cases, I will characterize it as good. So there's been both good and bad things, I think, that have occurred. The thing that the system engineering process introduced and codified and argued for was primarily a requirements basis for doing systems work. And that was a big deal in the 50s, although I saw evidence of it being done long before the 50s. But I think primarily Cy Ramo and Dean Woolridge and some other people, in a sense, articulated it, codified it, and made it happen. And their goal had nothing to do with software. Software was unknown and undiscovered in their eyes at that time. Their goal was to take multidiscipline things like ballistic missiles, which had aerodynamic contributions, propulsion, structures, guidance and control, 6 others, and cause these groups to work together in an effective way to build a system quickly. And that's what was, I think, the goal of system engineering. Okay. Now, the central unifying element in all this was the notion of a requirement. And system engineering glorifies the role of requirements and makes them the integrating phenomena through all phases, but also really through requirements controls the development. That was the message, the way things were thought about. And it worked very effectively. You probably don't remember, but maybe some of you do. In the mid-50s, we were in a terrible spot. The Russians had, of course, had the hydrogen bomb, and they'd invented ballistic missiles by which they could deliver the hydrogen bomb, mostly at us, and we did not have such a counter weapon. So General Schriever and some other people worked very hard to bring a balance back in. And it was that process, that need for a certain weapon, that really caused them to grab the system engineering concept and to work with it and make it the engineering approach to building, in this case, ballistic missiles. But they worked it out so you could build anything with it. Okay. And in this process, the requirement became God. Now, as the need for software and approaches to software came along later, this idea was appropriated by the military, or people close to the military, building for the military, to the way you ought to build software, including me. And it has, in my opinion, worked fairly well, but definitely not fully. And the problem that I see, and have seen over and over, is that a failure on the part of system engineers, system architects, and software people to make well-written requirements touch the code. And by touch, I mean scope the design, support the furtherance of the design, and so forth. Instead, in my experience, when I deal with requirements, well, put it this way, I send somebody to a meeting on requirements, some software person, and they come back and they say, "Hey boss, what does that have to do with me? I can code any way I want. I can design any way I want." There was nothing said that in any substantial way gave me any leadership or guidance or whatever on how to build software.